Probability, what are we talking about?
It's like the probability that something happens. So the chance that you have for something to happen.
Probability, you're saying, is the likelihood
Yes.
of an event happening. I agree with you. We don't have to. Anyway, the likelihood of an event happening, that's probability. Now, it means if we are 100% certain, it means it's 1, 100 of 100, clear. If you are 0%, it means it's 0. So if we are saying the likelihood, it means the probability can only be between 0 and 1. So it means in all your calculations of any probability question, if you see your answer being greater than 1 or less than 0, you are wrong. Clear? You are wrong somewhere. Because probability can never be greater than 1. Probability cannot be less than 0. We can't have a negative as a probability. Is that making sense?
Yes, sir.
So we have what we call theoretical probability. And we have what we call, can be used, practical probability. Are we together? Or it's called experimental probability. Are we together? So you find that theoretical probability, that's when, for example, if you toss a coin, you know that a coin has got a head or what? Or a tail.
Yes.
So if you say the probability of getting a head each time I toss a coin is half, this is theoretical here. Are we together? Why I'm saying this is theoretical, you find that if you were to, let's say a person throws 20 times, and he finds that the number of heads that he gets is 14, and the number of tails that he gets is 6, it's possible. So when you do this now, the probability is no longer this. This is just theoretical. The probability, if we're actually doing this, if we are given this, it means the total number you're doing it 20 times, the probability of getting a tail will be 6 over the total number, which is, are we together there?
Yes, sir.
So then we have what is called an independent event. What is an independent event at A level? What is an independent event?
I'm thinking, sir. Is this something that only happens once?
Not really. Can happen many times.
All right.
But if it's independent, if I say event A is independent from event B, what does that mean?
Okay, so that means
so if
that
I draw like this here, let me show you here.
So yeah. So
sure
if the one event doesn't affect the second one.
Yes. The occurrence of one event does not affect the event. So these events here are independent. A is independent of B, clear? Of B. Because the occurrence of A is not affected by B, clear? So there is no intersection between them, clear?
Yes.
Is not affected by B. So now in maths, now when you want to decide that something is independent, if I say probability of A, look at this, intersection probability of B, probability of A, intersection probability of B. Okay, maybe let me not talk about the independent, we'll talk about that later. Probability of A given that B has happened is simply equal to probability of A. Are we together? Because probability of B
Yes.
happening can never affect what? Can never affect A happening. Clear? So if you prove this in maths here, it means it's an independent what? Probability. Clear? Probability of B given A has happened is simply equal to probability of B. Is that making sense?
Yes, sir.
So this means the probability of A given B has happened. Probability of B given A has happened. It's simply probability of B. Now, this is true for independent. That's how we can prove. We'll do it questions where they say, now prove that it's an independent event using this, making use of this. Clear? Now, in general,
Yes,
probability of A given B is actually equal to probability of A intersection probability of B divided, you divide by the given, divided by probability of B. Are we together?
yes, sir.
So if I say here, probability of X given Y, it's probability of X intersection probability of Y divided by probability of Y. Is that making sense?
Yes.
Now let's look at the question. We try to
You just
analyze.
I just want to write the script down quickly.
Okay. Probability of X given Y.
Okay, we can watch the question now.
Okay, let's work together. So the first question, the probability that John is late to school is 0.65. Clear? Late to school is 0.65. How would you get that? Next part.
Yes, sir.
So I think the probability is late, okay? If John is late to school, the probability that he was driving is 0.2. Clear?
Yes.
If John is not late to school, the probability that he was walking to school is 0.4. Now the first part is that draw the probability tree diagram to represent this. tree diagram. That's the first part. Then we will do the given that we are talking about. Clear? Write the question, we work the question together.
I wrote the question. You can go.
Okay, so now we know that John is what? Can be late to school or not late to school. Do you agree from the first part? Very first
Yes,
part.
sir.
So let's go. I can use late L if you want, not late. So what's the probability that John is late to school? 0,
6.5.
what's the probability that he is not late? This should add up to 1, 0.35. So you say 1 minus that. Clear?
Yes, sir.
This should add up to 1. Because there are only 2 options. It's either you're late or you're not late. There are no other options. Now, if John is late, we are at this branch here. The probability that he is driving. So he can be driving or he can be walking. Clear? Walking, following, drive.
Yes, sir.
So what's the probability that he will be driving? 0, what? 0.2.
0.2.
So it means this is 0.8. Huh? Clear? Now,
Yes, sir.
if he is not late, we are at this branch here. So we have driving and walking. So what's the probability that is walking? 0.4, which means this is 0.8. 0.6. Heavy.
Yes, sir.
Now, to answer certain questions here, if I say, for example, I want to find the probability that he is late. So look at this, late. Probability that John is late to school. He can be late when he's driving, or he can be late when he's what? When he's walking. Do you agree?
Yeah. Yes, sir.
So it means it's 0.65 late multiplied by when he's driving plus 0.65 multiplied by 0.8. What do you get from a calculator?
It's 0.65.
0.65. Correct. Anyway, that's obvious. Huh? It was too obvious. And I simply wanted to show you something there. Clear? Now, what I now want to do here is to work with the given, the one that I was talking about. Huh? So now, if we say now the question says calculate the probability. Okay, late, not late. Okay, calculate the probability that he of driving given he is late. Clear? Like this. So this is probability, follow me. Probability of driving, remember what you said? Multiply or intersection, if you want it that way. It's multiplied by probability of what? Of later. Divided by the given. The given is the probability of being what? Being late. That making sense?
Yes, sir.
Okay, but this is not like a very good example. I will do just questions just now. The tricky one. Are you happy so far?
Yes, sir.
Now, so let's apply some questions. And we're just talking about the basics. So sometimes you need to know sets. So these are sets here. Start from sets. Now a survey is carried out into the sports viewing habits of people in a particular area. As part of the survey, 250 people. So your space is 200 universal set. We're asked which of the following sports they watched on TV in the past month. Football, cycling, rugby. Ready? So are we together? There.
Yes, sir.
Now, one of the students is one of you are selecting from all the people 250. Is that making sense? At
Yes, sir.
random. Find the probability that this person has in the past month watched what? Cycling, but not football. Cycling, but not football. So cycling, but not football, we can't include this. That making sense? Cycling,
Yes.
but not football. So 12 plus that. We are looking at the circle for cycling. 15, huh? So that's 15 over 250. You can reduce it or you can leave it like that. Clear?
Yes, sir.
Watched either one or two of the three what? Sports. Watched either one. Clear?
Yes, sir.
So if you are watching, it means rugby only, yeah?
Yes.
Cycling only, or rugby. And so let's take all two of the three sports. If you are watching two of the three sports here, you are watching football or rugby, you are watching cycling, follow me, cycling or what?
Yes, sir.
Or rugby, or you are watching football and what? And cycling, huh? Two. So we're dealing with two. So we're saying 14 here plus 65 plus 3 so far. If you are watching two sports, that. So now if we add here, that's 9, or if you want the other way. So this is 9 plus 3 is 12, huh? 2 carry 1. 7. So that's what? 82. But that's not the answer, that's not the total. So remember we said 1. What if you are watching rugby only? So it's what? 21, 33,
Yes.
12. Huh? So
Yes.
21, 33, 12. So adding that, this is 3, 6, 8. This is 10, 13, 14, 148. Clear? So 148 over 240,
250.
250, sorry. Clear?
Yes, sir.
Okay. Now, you see, now we are now doing the given that. Given that this person has watched the cycling. So now when you are doing this here, you don't have to do what I was doing here. You do that if it's a tree diagram. Now, the trick when you're doing sets here, we are no longer picking from all the people. We are picking from people that watch what? That watch cycling. Clear?
Yes.
So people that watch cycling are all people in this here. So what's 12 plus 14 plus 38 plus 3? You can use your calculator. 12 plus 12 plus 38 plus that. Because those are the people that watch cycling. 12, 38, 3, 12. So the 14, that 26, I think. 29 plus 38, what do you get?
67, sir.
67. So now it means your space here is 67. It's no longer over 250. Yeah? Find the probability that this person has not watched what? Football. This person has not watched football. So look at this. We don't want all this here because this includes football. Can you see that?
Yes.
So it's 15. Is that making sense? But now 15
Yes.
over 67. See how easy that is?
Yes, sir.
I like very basic questions. Now let's look at this. It's a better draw a tree diagram. So can you try that tree diagram? I'll give you a minute to read. I want you to try to draw the correct tree diagram there.
So okay, I'll do it.
Let me know if you're done.
I'm almost done, sir.
Okay.
Okay, I'm done, sir.
Okay. So we have John is applying for a okay for a large company. They're taking an amplitude. Right. Okay. Happy should test. They are the accepted, rejected. Okay. So you have exception. I'm sure you agree. Okay, let me look for where I have space here. You can even use that, it doesn't matter really. Let me use below, slightly below. So something like this, 3 branches. Huh? You're either accepted, do you agree? Rejected, or retested. That's true.
Yes.
Wait a moment. Check a test on which they're either accepted, rejected, or okay. So probability of being accepted is 0.2, 0.5, then 0, what? 0.3. Yeah? When the candidate is retested for the first time, the 3 outcomes, okay, for the first time, comma, the 3 possible outcomes and their probabilities remain the same as the what? As the original. Clear? For the first time, like this. So
Yes.
it means accepted, rejected, retested. So they are remaining the same. 0.5, 0.2. Do you agree?
Yes, sir.
When a candidate is retested for the second time, there are 2 possibilities. Accepted or what? So is the candidate is now doing it means he's taking a retest. Huh? So it means you either rejected, like what you said, or what? Or accepted. Huh? So or the other way, just the same. So accepted is 0, what? 0.4. Rejected is 0.6. Do you agree? Like that, huh?
Yes.
If you are rejected, you don't take a retest, which makes sense. If you are accepted, you don't make a retest. Huh? Was that your tree diagram exactly like that?
Yes, sir.
Okay, that's good. You now know tree diagrams for A level. Slightly different from O level. Now, find the probability that a randomly selected student is accepted. So look at our tree. We have accepted for the first time, which is 0.2, plus you can take a retest and be accepted. Is that making sense? Which is
Yes, sir.
0.3 multiplied by 0.2. Or you can be retested twice, which is 0.3 multiplied by 0.3. Then you are accepted. Is that making sense?
Yes.
0.4. So that's 0.2 plus 0.06. You can check in a calculator. Then what do you get here? 0.3 times 0.3 times 0.4. Like 36. Do something like this, but anyway, check in a calculator. So what do you get here? That plus that plus that. Use your calculator. What do you get? Okay.
Sorry, so the ones at the bottom, is it 0.2 plus 0.06?
Just do this here. I was
Oh,
just
just
doing
top,
this
okay,
because I
sorry.
was doing manual. Okay, guys, this maybe I was wrong here. Simply 0.2 here plus 0.3 times 0.2 plus 0.3
It's
times 0.3 times
0.23.
0.23.
23. Yes, that is what I'm getting from the top.
From this here.
Yes. Is it wrong?
Yeah, I'm not sure. I'm asking.
I'll do it again, but I'll do it again.
Let me check here. I was doing mental math, so was my calculator is fine. Okay, 0.3 times 0.3.
Oh wait, no, now I'm getting something else. 0.74.
No. 0.2 here. Plus, this is a plus.
Yes. Yes.
0.3 times 0.2. Then plus here. 0.3 times 0.3 times 0.4. The answer will be
Yes, and that
0.2 something.
yeah, 0.2296, so it's 0.3.
Yeah. No, you can't round it. It's a perfect
Oh,
answer.
you should I just leave it like that?
Yeah, it's a perfect answer. Why should you round it?
Ah, all right.
Because you get this minus, Max. You don't
Alright,
round
so
perfect answers in maths.
296.
Are we together there?
Yes.
So look at the last part now. Find the probability that a randomly selected student is what? Is retested. At least what? At least once. Huh?
Okay.
At least once means one or more times. Huh?
Yes.
Okay. One or more times.
One or more times treated, but it has to be
So,
accepted first.
given that is what? Is accepted.
But
So
does that mean it's accepted at the end? Or
what it means, let's work with what we said. So probability of retest twice. Let's just say retest to whatever. Given that what you are accepted. Clear? Given you are accepted. So if you check your notes, I said this is equal to probability of a retest twice intersection accepted. That's what it means. Divided by
Okay.
what is given. Given what? Your what?
Except.
Yeah, accepted. Probability of accepted is what we calculated here. We don't have to recalculate it this year. It's what we calculated in this part here. Otherwise, we are doing long working. Clear?
Yes.
So
Sir.
probability of accepted, we have it. It's 0.296. And what we don't have is this here. Probability of taking at least whatever intersection what accepted. So it's all this here. Can you see that? That's
So
that's
are we supposed to do it twice for the retest once
yes,
and
at
then
least
one
yes,
for retest twice?
at least once means one or more times.
Okay.
Is that making sense?
Yes, sir.
So that times that times that. So what do you get?
I'm doing quickly.
0.3 times 0.3 times 0.4 divided by 0.296.
It's a very big number.
No, what do you mean? A very good one. There you get what here? 0.036, I think. Divided by 0.296. No, what's the fraction? I want the fraction.
The fraction is 9/74.
Yeah.
Oh, okay.
It's clear?
Yes, sir.
Now, I think it's time for a break. We'll see you at 21 first.
Thank you.
Mike, so how am I? Mike, you. Right. Dos vários, sim, dá. Não, não. Hi.
Hello.
Okay. Yeah, back.
Yes.
Now, each weekday, mother travels to school by bus. Sometimes she arrives late. L is the event that mother is late or arrives late. R is the event that it is raining. Okay. You are given that the probability of late is 0, which means probability of not being late is 1 minus that. Okay. Probability of R raining 0, what? 2, 2. Huh? Now, then the probability of it means late given that it's raining. Can you see that? Late given it's raining 0.45. Use this information to show that these events are not what? Are not independent. Can you see that?
Yes.
Now remember what I said. I said if they are independent, probability of late given that is raining, late is not affected if they were independent. Clear? It means probability to be simply equal to probability of late. Are we together? So if we want to prove that they are not independent, it means if they are independent, they should give us this. Clear? So now let's use our formula. Probability of late given that it's raining is equal to probability of late. Look at this. Multiply, remember that's what we said, intersection, probability that it's raining. Like this. That's what it means. Huh? L intersection R, you multiply. Clear? Divided by the given that is what? It's raining. Clear? So probability of late is 0.15. Multiply by what's the probability of raining? 0.22. Do you agree?
Yes, sir.
Divided by probability of raining, which is 0.22. Wait a moment. Did I make a mistake? Oh, I see. I made a mistake here. My apologies. So I see that. What is our answer here of probability of late given it's raining? It's 0.what?
0.45.
Okay. So look at this. Cross multiply. Probably. So what I can write here, that probability of L, that's what I want to do here, is equal to probability of L intersection like this, divided by probability of the given. Now cross multiply, it means probability that we are not given, late given is raining, look at this, it's equal to probability of late given raining multiplied by probability of raining. I've just cross multiplied here, clear?
Yes, sir.
Then let's use the values that we have. This we are given 0.45. Multiply by probability of late 0.22. What do you get? What do you get?
It's 0.099.
0.99.
0.99.
That's this here. The first part, yeah? Clear? Are you following? To show that
Yes,
this
sir.
is the 1 mark here. So you can simply say, right, the probability of, if they were independent, probability of late should be equal to probability of late given it's raining. But it's not the same here. So it means the raining is affecting the probability of being late. Clear?
Yes.
Because if it was independent, then this here should be exactly equal to this. So this is not equal here. Well, this is 0.15. It's not equal to 0.45. That's why it's simply 1 mark. Clear? Then I've calculated this for you here. Are we together?
Yes, sir.
Now the last part, the tricky one, is the Venn diagram. Let's see. What a tricky question. So we have late and raining. They have got an intersection which we found together. So that intersection is 0,099. Do you agree? There.
Yes, sir.
L. Now, follow me. Probability of raining. Everything here in raining is 0,22. So 0,22 minus the intersection here, minus 0,099. We get what? We want raining only here. We subtract the intersection. 0,22, everything here. So 0,22 minus 0,099. What do you get?
It is 0,121.
0,121.
121.
Now, this here, late only, it doesn't involve late and raining. So it's also 0,15 minus 0,099. What do you get?
0,015.
0,015. Now, is there a condition which is outside the universal set? Everything should add up to 1. Otherwise, there's something here that does not involve late or raining. So add that plus that plus that to see if it gives you 1. Otherwise, if it doesn't give you 1, we subtract from 1. 0,015 plus 0,099 plus 0,121.
It's 0,235. 235.
Are you sure?
0,099 plus 0,015 plus 0,121. Yes, it's 0,235.
So we now say 1 minus 0,235.
35.
What do you get? That is what is outside there.
It's 0,765.
765. Are we together then?
Yes, sir.
You are not late, it's not raining there. Outside there. Maybe.
Yes, sir.
Now let's look at number 5. Each week, Alan arrives to work, drives to work. So on his journey, he travels over a level crossing. Sometimes he has to wait at this level crossing for the train to pass. W is the event that Alan has to wait at the level crossing. L is the event that Alan is late for what? Awake. Huh? Clear?
Yes, sir.
Now you see, they love this question there. So now let's work with this here. Probability of L given W. Now you should know. It means probability of L intersection what? W divided by the given. Isn't that what he said? Like this. Do you remember that?
Yes, sir.
Now we want this here. So cross multiply. It means probability of L intersection W is simply called probability of L given W multiplied by probability of W. Abby? We have this here. It's 0,4 multiplied by probability of W 0,07. What do you get?
It is 0,028. 028.
That's the intersection. Huh? Clear? Now the Venn diagram See, I've got space here. So what's the intersection? 0, 0, 2, 8. Heavy?
So,
Probability of W is 0,4. You now know what we did here. So 0,07, sorry. So 0,07 minus 0,028. What do you get? Find W only.
0,042.
0,042. 042. Now look at this here. Union means intersection plus what's in W only plus what's in L only. Can you see that?
Yes, sir.
So it means I can now say 0,08 since this is the intersection 1, 2, 3. Sorry, I can now say 0,08 minus 0,028 plus 0,042 like this. What do you get?
Zero comma 0,01.
Now add everything here, see if it adds 1, otherwise we've got something outside. Adds up to 1, I don't think so.
No, it's 0,8.
So 0,8 everything.
No, it's 0,08.
Is 0,0 is here. 0,08. So it's 1 minus 0,08. You get 0, what? 92, is that correct?
Yes.
Determine whether L and W are independent. Explaining your answer. They have an intersection here, they are not independent, or you can actually prove it. So if they were independent, probability of L given W should simply be equal to probability of L. This here, clear?
Yes.
Now probability of L from this diagram here was 0,01 plus 0,028.
Um, 0,038.
Yeah, 0,038 is not equal to 0,4. So they are not independent. Clear?
Yes, sir.
Now Malika is playing a game in which he has to throw a 6 on a fair-sided die to start the game. Find the probability that he throws a 6 for the first time on the third attempt. Clear?
Yes,
So
sir.
look at it. It means the first time he doesn't get a 6. The second time he doesn't get a 6. The third time he gets a what? A 6. So what's the probability of getting a 6 on a fair-sided? Fair-sided, it means a die is 6-sided. It's 1/6
Yes.
because you only have
Yes.
1 6 on a die. Then the probability of not getting a 6 is simply 1 minus probability of getting a 6, which is 5/what? 5/6. Clear?
Yes.
So there is probability of not getting a 6 multiplied by probability of not getting a 6 multiplied by probability of getting a 6 on the second time. So on the 6 on the third time. So that is 5/6 multiplied by 5/6 multiplied by 1/6. What do you get? Use the calculator. Is that correct? 5/216.
Yes.
He needs at most how many throws? 10
Say it again,
attempts.
sir.
The next part. He
Oh,
needs
10
at
attempts.
most. At most means what in math? Means less
So
than
it's
or
10
less
and-
than less
yeah,
than or
10 or
equal to
less.
10 or less. Huh? 10 or less. Ten or less. 10 or less, isn't that 1 minus probability of greater than 10? Do you agree?
You sure?
Because you're saying 10 or less. Means at most, so 1 minus probability of greater than 10. 10 or less. Oh, sorry, at most 10 attempts. So, or I think it's just simply 2 marks. So if you are saying 10, we said the probability of not getting is 5/6. Huh? Do you agree? So if you're saying 10 attempts, so if it's 10 attempts, that means for 9 attempts, you're not getting anything. Do you agree?
Yes, sir.
On the 10th attempt, that's when you're getting a 10. What did you get from a calculator? I think it's a big number.
Yes, very big number, sir. It's like 0.0323 and a lot of
Okay,
stuff after
but
that.
sometimes you give it as a fraction.
It didn't come up as a fraction.
Oh, that's a I'm surprised I didn't give you a fraction. Let's see the next one. Unfortunately, they become mixed together. It does not know which of the bulbs. Mhm. Find the probability that all the 3 bulbs produce what? Blue flowers. So blue flowers out of 50, 30 produce what? So probability of blue is 3/5. Do you agree? Probability of red is 2/5. from that question. Do you agree?
Yes, sir.
Now, she is buying 3 from a box containing what? Containing 50. Yeah? Do you agree?
Yes.
Right there. So the first time she's going to, so the probability will not remain the same. I'll show you why. The first time she's picking 1 bulb from 30 over 50. Clear? Multiply by, because now you have taken a bulb or you've bought a bulb, you are no longer left with 30 of these. They are now 29. Clear? That
Yes.
produce blue flower. But now because you have bought 1, you are left with 40 what? 49. Clear? Multiply, now you have taken 2 blue ones, you're left with 28 over 48. Because you have taken 2. Clear? Because you are picking without replacement. What do you get? Oh no.
It's 29 over 140.
Okay. Heavy?
Yes, sir.
Find the probability that Karen will have at least one flower of each color. One flower from the 3 what? Bulbs. Let's see what it means. Look, I want to, before we do calculations, let's just think of what it means. It means I can have from the 3, I can have 1 color. So I can have, or at least 1 color. So I can have blue, red, red. Do you agree? Like that.
Yes.
It means my first choice is blue. I can have red, blue, red. Having 1 blue. I can have red, red, then the third choice is blue. I can have probability of, just want to show you something, what it really means. I can have blue, blue, red, 1 red. I can have red, red, oh, sorry. Red, red is what we did, that 2 reds. So I wanted 2 blues here. So I can have probability of blue, blue, red. Clear? Can have probability of blue, red, blue. I can have probability of red, blue, blue. Clear? But it means
Yes, sir.
we are talking of 1 here. Now, but we can have 2. 2 includes, if I have 2 reds and 1 blue, it includes what we have just right there. But I can also have 3, which is probability of, because at least, wait a moment, at least 1 color. Also, it means we can't have red, 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 because we need at least 1 color. Clear? So that's all. Do you agree?
Yes, sir.
No, I want you to analyze this. So this here, I'll show you what it means. You can actually multiply by 3 because they'll be the same. So this means if I'm to pick this here, this combination, blue is 29 over 50. Yeah? Multiply by red. Red, how many reds do we have? 20. But we have taken 1 blue, we are left with 49. Follow me. Multiply by another red here. We had 29 is 19 over what? Now over 48. Is that making sense?
Yes, sir.
Now, this combination here will be the same. It's only the denominator that will be changing here, the numerators, but the denominator will remain the same. So you multiply this by 3 here. Plus this other combination here. And now 30 over 50. Multiply by blue is now 29 over 49. Multiply by red, we haven't picked any red, 20 over 48, like this, which is slightly different from this. Multiply again by what? By 3, yeah? So do this here, multiply by 3, get the fraction, do this multiply by 3, then add the two fractions. How are you together? But what I wanted to show you, do you know what I wanted to show you? Was the easy way. Can you see that this is as good? Your answer here, I want you to do that answer. You'll find that I'll do the shortcut. It's 1 minus probability of flowers of same color. Why am I saying so? That's the only combination that is not here when they are of the same what? Color. Remember, we found blue here. So now I want to do red and see if we get the same answer. So if they were all red, it means 20 over 50 multiplied by 19 over 49 multiplied by 18 over 48. Can you tell me what fraction you get here? What fraction do you get? Or you're still calculating the others?
I'm still doing the other one. I'm almost over there.
Okay. Want to prove it, I don't get the same answer.
So I said the previous one, the one on top, is both times 3 or is it to the
Times
power of
3.
3?
You know,
Times
times 3. Is this,
Okay.
this here? It's times 3. Then here you calculate what's inside the brackets, you multiply by 3 also. Then we add whatever we get here, we add to this here. But we don't forget to multiply by 3. These combinations here.
The one at the bottom, it's just that you don't have to times 3 or something again. The one at the bottom, it's just you don't have to do anything times 3 again. It's just that.
Look at what I said here. I said whatever answer we're going to get here is the same as 1 minus of the same color. So I wanted you to find out what is. So this here is probability of red, red, red. We remember this one, the first one we found blue, blue, blue. So we need to add those and subtract from 1 minus of the same color. So what do you get here? Was there you got your first answer that you told me. What do you get here?
It's for that one. It is 57 over 980.
57 over
980.
980. And for the first answer, yeah?
The first one was 36 over 49.
Hmm?
36 over 49.
36 over 49.
For which one? For the top one.
This one, yeah, top one. Yeah.
Okay, wait. Just wait. It's 29 over 140.
Yeah, 29 here over 140. Like this. That's what I mean here. Blue plus red. So 1 minus, what do you get? 1 minus in brackets 57 over 980 plus 29 over 140. You should get the same answer that you got there when you're multiplying those.
Yes, the same.
Yeah, that's what I meant. It's the same. So I think if you can do numbers, try number 6, but maybe you'll be stuck on the last part here. It's probably, I'll send the paper. This is to do with binomial, but these two here, you can do it clear.
User.
Okay. So we see you on Thursday, is that correct?
Yes. Yes, sir.
Oh.